The universe is often imagined as a grand tapestry filled with galaxies, stars, and glowing clouds of gas. But hidden within this cosmic architecture are regions so vast, so eerily silent, that they feel almost forgotten by creation itself. Among these silent realms lies one of the most unsettling and puzzling structures ever identified, the Boötes Void. It isn't just an empty patch of sky. It is a gargantuan desert carved into the fabric of the cosmos, stretching hundreds of millions of light years across, and containing only a handful of lonely, isolated galaxies that drift like stranded ships in a dark ocean. For decades, astronomers have stared into this immense nothingness, trying to understand how such an enormous absence could exist in a universe otherwise crowded with matter and motion. The Boötes Void challenges our sense of scale, our understanding of cosmic evolution, and perhaps even our assumptions about how the universe chose to shape itself. And as we explore its depths, we step into one of the strangest mysteries the cosmos has ever offered. The story of the Boötes Void begins in 1981, when astronomer Robert Kirshner and his team were mapping galaxy distributions in the night sky, and stumbled upon something that shouldn't have been there at all, a staggering absence. While charting the positions of thousands of galaxies, their data revealed a massive spherical region that seemed almost completely empty, as if someone had carved a hole out of the universe itself. At first, the team assumed it had to be a measurement mistake, a glitch, a miscalibration, anything but a 300 million light-year void. But as more observations poured in, the truth became unavoidable. This wasn't noise in the data. This was a genuine cosmic desert, so large and so empty that even seasoned astronomers struggled to comprehend it. The discovery was not just surprising, it was unsettling, challenging everything scientists thought they understood about how matter clusters and spreads across the cosmos. The universe is far from a random scattering of galaxies. Instead, it is woven into a vast cosmic web, a delicate yet immense network of filaments and nodes stretching across hundreds of millions of light years. Galaxies cluster along these filaments, forming massive superclusters at the intersections, while the spaces in between remain remarkably empty. These nearly empty regions are what astronomers call voids. Most voids are sparsely populated, but the Boötes Void stands apart as one of the most extreme examples. Its sheer size, hundreds of millions of light-years across, and the astonishingly low number of galaxies within it make it an anomaly in the cosmic web. This void challenges our understanding of how matter is distributed in the universe, forcing scientists to reconsider the fundamental processes that shape the large-scale structure of everything we can see. In essence, studying voids like Boötes is like peering into the negative space of the universe, revealing the hidden architecture that dictates how galaxies, clusters, and the vast emptiness between them are arranged. The Boötes Void is not just large, it is almost unimaginably vast. Stretching nearly 330 million light-years across, it dwarfs even the largest galaxy superclusters. To put this into perspective, if the Milky Way were a single grain of sand, the Boötes Void would be roughly the size of a continent. Within this colossal emptiness, galaxies are few and far between, scattered like tiny islands in a cosmic ocean. Such an enormous void forces us to confront the limits of human intuition. It is a region so immense that the mind struggles to grasp its true scale. Astronomers often use analogies and models to try to visualize it, but even the most sophisticated simulations can only hint at the emptiness that dominates this region of the universe. In the context of the cosmic web, the Boötes Void stands as a profound testament to the vast, intricate architecture of the cosmos, and to the mysteries that still lie beyond our comprehension. Boötes Void's extreme emptiness has puzzled astronomers since its discovery. Several scientific theories attempt to explain this cosmic anomaly. One possibility is that it formed from the merging of smaller voids in the early universe, creating a supervoid so vast that very few galaxies could form within it. Another factor may be variations in matter density. Regions with lower initial density would naturally produce fewer galaxies over billions of years. Additionally, dark energy, the mysterious force driving the accelerated expansion of the universe, may have played a role in amplifying the void's growth. Despite these theories, no single explanation fully accounts for the void's size and sparse population. Studying Boötes challenges scientists to refine their models of cosmic evolution and reminds us that the universe still holds secrets far beyond our current understanding. Despite the overwhelming emptiness of the Boötes Void, a handful of galaxies persist, scattered like isolated jewels in a vast cosmic desert. These lonely galaxies survive in extreme isolation, with no nearby neighbours to influence their evolution. In such solitude, star formation can continue undisturbed, yet interactions with other galaxies, a crucial driver of galactic growth, are rare or non-existent. Astronomers study these isolated systems to understand how galaxies evolve when stripped of the gravitational tugs and mergers that shape galaxies in denser regions. Each of these solitary galaxies tells a story of survival against the odds, highlighting the resilience of cosmic structures even in the most inhospitable expanses of the universe. The origins of the Boötes Void reach back to the earliest moments of the universe. In the aftermath of the Big Bang, matter was distributed unevenly across space, forming dense regions that would become galaxies and clusters, and sparse regions that would remain largely empty. Somehow, in the area now known as the Boötes Void, conditions prevented the usual clustering of matter, leaving a colossal expanse almost entirely devoid of galaxies. Cosmologists use simulations to explore these early cosmic processes, tracing how small fluctuations in density could have been amplified over billions of years to create the supervoid we observe today. Understanding these formation mysteries not only sheds light on Boötes itself, but also challenges our broader understanding of how structure emerges in the universe. The universe is not a random scattering of galaxies. It is woven into a vast cosmic web. Filaments of dark matter stretch across millions of light years, pulling ordinary matter along with them to form galaxies and clusters at their intersections, known as nodes. Between these filaments lie enormous voids, regions nearly empty of galaxies, which grow as matter continues to flow along the filaments. Studying the cosmic web helps astronomers understand how gravity sculpts the large-scale structure of the universe, and why voids like Boötes exist as colossal empty expanses surrounded by filaments teeming with galaxies. The Boötes Void presents a challenge to our understanding of cosmic evolution. According to the lambda-CDM model, matter should cluster in predictable ways, yet this enormous void seems to defy expectations. Its sheer size and emptiness raise questions about the accuracy of simulations and the role of dark energy and dark matter in shaping the universe. Astronomers are left puzzled. How can such a vast region remain nearly empty while surrounding areas teem with galaxies? Studying Boötes forces scientists to refine their models and confront the possibility that the universe may hold structures and behaviours that are far stranger than previously imagined. While traditional models provide insight into the Boötes Void, Scientists also explore advanced speculations that remain within the boundaries of known physics. Some suggest that subtle variations in dark matter, distribution, or early fluctuations in cosmic inflation could have exaggerated the void's size. Others examine the interplay of dark energy with surrounding filaments, considering whether it accelerated the evacuation of matter from this region. These theories remain speculative, yet they are grounded in observation and simulation, pushing the boundaries of our understanding and challenging researchers to think creatively about how the universe sculpts its larger structures. Studying the Boötes Void presents unique observational challenges. Its immense size and extreme emptiness mean that very few galaxies are available to serve as markers for mapping. Light from these distant galaxies is faint, requiring powerful telescopes and long exposure times to detect. Additionally, intervening cosmic dust and gas can obscure or distort observations. To overcome these difficulties, astronomers rely on advanced surveys, simulations, and indirect measurements, piecing together the structure of the void and its place within the cosmic web. Every observation is a small victory against the void's overwhelming silence. As the universe continues to expand, the Boötes Void may grow even larger, stretching its emptiness across an ever-increasing region of space. Galaxies within and around the void may drift farther apart, leaving even more isolated systems. Filaments surrounding the void could become more pronounced as matter continues to flow along them, accentuating the contrast between the dense cosmic web and the vast emptiness within. Simulations suggest that over billions of years, the void will evolve into an even more desolate expanse, offering scientists a glimpse into the long-term dynamics of the universe and the enduring power of cosmic expansion. The Boötes Void stands as one of the universe's most profound reminders of emptiness and scale. In its vast silence, we are confronted with the limits of our understanding and the extraordinary nature of cosmic structure. This enormous, lonely expanse challenges not only scientific models but also our imagination, prompting reflection on the fragility and resilience of matter across the cosmos. As we conclude our journey through the void, we are left with a sense of awe, humbled by the quiet grandeur of a universe that holds both dazzling clusters and immeasurable emptiness side by side.